Kerbel turned for help to the Natural History Museum in Vienna, whom he's worked closely with in the past. Using their electron microscope, he searched the desert glass for a mineral called zircon. Zircon is remarkably stable, but starts to break down at high temperatures. Kerbel looked for zircon crystals that had begun to disintegrate.
And what this tells me is that the glass formed at a very short time and a high temperature. And to understand exactly which temperature we're looking at here, I need to analyze the different bits inside here.
As the zircon disintegrates, it forms light and dark patches. In the dark patches, the zircon has broken down into a form of silica. The amount of zircon left in these areas shows how far the disintegration has progressed and indicates the temperatures reached.
In the darker areas, we have less zircon and more silica. And what this tells us is that this little zircon crystal has decomposed partly because of the high temperature, but not completely. And the ratio of the two elements tells me that the temperature was about 1,800 degrees Celsius.
1,800 degrees Celsius is hot, incredibly hot. Volcanic lava is only about 1,100 degrees Celsius. Whatever happened here in the desert, the heat required to produce the glass was phenomenal. What Kerbel found convinced him and everybody else that they had to look for another explanation. There was only one thing they knew of that could create such a staggeringly high temperature that it melted the ground. A meteorite impacting with Earth.
So there's a lot of material that falls on the Earth from outer space. Tons and tons of this material falls on the Earth every day. And most of them are very small, just like dust. Some of them are pebbles, and they make shooting stars in the atmosphere. And sometimes a really big meteorite hits the ground at very, very high speed. It melts the ground, it vaporizes the ground, and these high temperatures and pressures are enough to melt a huge quantity of rock.
If the molten rock formed by a meteorite impact cools rapidly, it can turn into glass.
There are, for example, these glasses here. They're called tektites, and they are thrown away from impact by hundreds and even thousands of kilometers from the crater. But these glasses are very different in appearance and shape and size from the desert glass that we have here.
Kerbel is a world expert on meteorites. And even though the desert glass is so different from ordinary meteoritic glass, he is convinced it must have been formed by a meteorite. He hopes to find evidence of a massive meteorite impact in the desert. They still have one more day of driving before they can even start looking for any glass or any signs of what occurred. They are now in the heart of the Great Sand Sea. It's one of the most arid, inhospitable places on Earth. No one can live here. It can be 10 to 20 years between rainfalls. Extreme conditions even for the Sahara.
If we go a little further down,
we are here.
And on this one here,
we are here, and then the glass area is all this area. We'll camp at the end of the rocks and the sand here. Like that, we'll make the camp sort of in the middle of the high concentration of the big glass.
just one.
Yeah,
This,
25
this
or
one,
5.
not this.
Summer temperatures can soar to well over 50 degrees Celsius. There are no roads, no tracks. The massive parallel sand dunes stretch for hundreds of kilometers north-south. Each dune is a challenge, and without highly skilled drivers, the cars could easily overturn as they slide down the soft sand. At last, they are approaching the area where the glass is found. One of the mysteries about the glass is that it's scattered over an area as big as Devon.
The site to me looks like Mars. I don't think there's any place on Earth that's this desolate, certainly no place I've ever been.
The glass is not thick on the ground, but pieces can be found scattered between the dunes.
I'd seen pictures of the glass before, but the first time I reached down and picked up a piece and held it up to the sun, it was very exciting.
No one knows how much glass is in the desert. Estimates range from hundreds to thousands of tons.
Oh, here's a piece. Oh, look at this. There's a nice one. And another one. So this is an area, and look down here on the ground. You can actually see it. If you look here, you see the nice pieces lying around here. There is a piece here. There's a piece there. There's a piece over there.
Most of the glass lying on the surface is small and rounded, sandblasted and polished by the sand and the wind. Other pieces are buried in the sand and are much larger and rougher.
This one here is mostly pitted and dull because it has been sitting underground, and only the nice smooth shiny part was exposed to the sand, and underground it has been etched by water over hundreds or even thousands of years.
New pieces of glass can always be found, as the huge sand dunes are constantly shifting with the wind, moving at a staggering 10 meters a year.
It's interesting, every time you come here you find different glass.
There's certainly glass under the dunes.
There's certainly glass under the dunes.
As these
the
dunes
move,
they
more
reveal
glass
more
is
glass.
exposed indeed, yeah. So it's a very beautiful area too.
Yeah.
Although there are no obvious signs of meteorite impact, Barakat thinks there is some evidence, not in the glass, but in the rocks. On a previous trip, he found an unusual little black rock.
I collected it by chance. I found it by chance. I was looking for glass, and I found this strange, shiny black material. So it seems strange for me. So I carried to Cairo and did some tests.
And tests in Cairo revealed that tiny, shiny particles in the rock were diamonds. Similar diamonds have been found elsewhere where meteorites have landed, created by the high temperatures and pressures during the impact. Barakat is now searching for more signs of an impact in the sandstone rocks in the area. A large meteorite smashing into the ground leaves behind other clues. Under the microscope, the tiny grains of quartz, which this sandstone is mostly made